So determine the forces in bars AC, FG, and BD of the plane truss supported and loaded as shown below. Angle DBA is 60, so this is 60 degrees, equal to angle CAB also. And angle CBA is 30. Angle DAB is also 30 degrees. So the horizontal component of reaction is 0 because there are no inclined load. Vertical AV, and this is R sub B. Then this angle is 30 degrees. The whole angle that CAB is 60, so this is also 30, 30 degrees, 30 degrees. Therefore, because ADB is a right triangle, 90 degrees at D, same is true with ACB, 90 degrees at C. Therefore, this is the hypotenuse, which is 6B, sine of 30, so that means this is 3B length. That's also 3B. Then the vertical distance is 3B sine of 60, so it is 2.5981B. While this horizontal distance is 3B cosine of 60, so 1.5B. Horizontal distance between D and B also is 1.5B. So we will call this theta 1 also by symmetry. This is theta 2, and this is also theta 2. So tangent of theta 1 is 2.5981B over this distance, which is 5B minus 1.5B, 3.5B. So tangent theta 1 is 2.5981B over 3.5B, cancel B. So theta 1 is 36.587 degrees. Again, theta 1 is arctan of 2.5981 over 3.5, where 3.5 is 5B minus 1.5B, which is the same as that. Then tangent theta 2 is 2.5981B over 4B minus 1.5. So 4B minus 1.5B is 2.5. So theta 2 is arctan of 2.5981 over 2.5. So theta 2 is 46.102 degrees. Then this is 3B because the total length is 6B minus 1.5B, then minus 1.5B, so 3B. Then that's also theta 2. Moment A0 to solve for RB. Counterclockwise positive. RB times 6B equals RB times 6B minus Q times B minus 2Q times 2B minus Q times 4B, then minus 2Q times 5B. Cancel out B, then we can solve RB. RB is equal to 19 over 6 of Q. Then we begin with joint G to solve for FCG, and we proceed to H to solve for FCH. Then knowing these two forces here, we isolate joint C as a free body diagram because we want FAC and FBC. Take note, FAC and FBC are perpendicular or 90 degrees at C. So these are the forces involved at joint G. This is required, so that's why it's red. That's FFG. So therefore, RG vertical equals 0. Our equation or summation forces vertical equals 0 at G. So this is FCG sine of theta 2, sine of 46.102 degrees, then minus Q. So from here, we can solve FCG in terms of Q, 1.3878 of Q. Then at joint H, these are the forces. So RH vertical equals 0. So FCH sine of theta 1, FCH sine of 36.587 upward, then minus 2Q equals 0. So FCH is equal to 3.355Q. Then we draw the FBD of joint C. Remember that FAC and FBC are perpendicular to each other, and the angle that 3.355Q CH makes with the horizontal is 36.587. theta 1, the angle that 1.3878Q, which is FCG, makes with horizontal is 46.102. But the angle they make with BC is, this one is 36.587 minus 30, so 6.587. The angle that 1.3878Q makes with BC is 46.102 degrees minus 30, so 16.102. So we set, let's call this U axis. RCU equals 0. FAC is in that direction, so equals FAC. The component of 3.355Q in that direction is plus 3.355Q sine of 6.587, where 6.587 is 36.587 minus 30. Then the component plus 1.3878Q sine of 16.102, where 16.102 is 46.102 degrees minus 30. So from there, we can now solve FAC, which is negative 0.7698Q. And that's the answer. FAC is 0.7698Q compression. Then we need FBC, so that if we solve FBC, we can now proceed to joint B. Then we can solve the force in FBD, which is also required. So R sub C, let's call this V axis, not vertical, but just V axis. So RCV equals 0. So take note that FBC has no component along U in the same manner that FAC has no component along V. So it is equal to FBC plus 3.355Q cosine of 6.587, this angle here, then plus 1.3878Q cosine of 16.102, the angle that this force makes with the V-axis is 16.102, and it is cosine. So FBC is negative 4.6666Q. Then we proceed to joint B. These are the forces. And take note that this is FBC, which is known. This is FBD, which is unknown. So the equation is simply RB vertical equals 0, or summation forces vertical equals 0 at B. So FBD sine of 60, the vertical component of FBD, plus the vertical component of FBC is quantity, plus FBC sine of 30, then plus RB. So substitute FBC, which is negative, so FBD sine 60 plus FBC, which is quantity negative 4.666Q sine of 30, plus RB, which is 19 over 6 of Q. So from there, we can now solve FBD in terms of Q. FBD is equal to negative 0.9623Q. So FBD is 0.9623Q compression also. Then we consider FG is left. We consider section 1-1 and all forces to the right of that section. Because these three green forces meet at C, so it is best way to sum up moments about C, or M sub C equals 0. Considering clockwise positive, so FFG, moment arm 2.5981, OB, that's plus, then plus Q, clockwise also. Q, moment arm is 4B minus 1.5B, so 2.5B, plus Q times 2.5B, plus 2Q times 3.5B, plus B. Then minus RB times 4.5B. Then there is one more left, FBD. So by principle of transmissibility of a force, take note, we sum up moment about C. Imagine that FBD is moved at D. Then there are two components of FBD, horizontal, which passes through C, so don't mind. Then the vertical, which is FBD sine of 60, then the moment arm is 3B. So minus FBD sine of 60, then moment arm is 3B. Take note that I move FBD to D by principle of transmissibility of a force, so that it has only one component, the vertical component, moment about C. It's the same if you do not move, but this is the simpler one. By experience, we always did this in most problems in statics, unless this is your first time. So substitute 0 equals FFG times 2.5981. I cancel out B. Then combine these two Q's here without B. So 9.5Q, 2.5 plus 2 times 3.5, so 9.5Q. Then RB is minus RB is 19 over 6Q times 4.5. Then minus FBD, which is FBD is negative 0.9623Q, because it is compression, times moment arm 3 sine 60 after we cancel out B. So from there, we can now solve FFG in terms of Q. So FFG is 0.8660 of Q. Because it is positive, it is tension. So that's it for this problem.